It's hard to escape news headlines about bushfires. These days, it seems there are bushfires always burning somewhere. We've seen devastating reports from across the globe, from the Arctic to Canada to Greece to Australia. The science speaks for itself. Climate change is increasing bushfire risk through higher temperatures and drier conditions. Bushfire seasons are commencing earlier and lasting longer. In this video, we will explore how science is helping to tackle this increasing threat and how we're helping communities build resilience and prepare.
What we've seen happening over the last probably 2 decades or so is a much greater frequency of what we would call high fire danger days, where if a fire was to occur, its behaviour is likely to be much more severe than it would be under moderate conditions.
It feels like climate change is taking off quicker than we're even improving in its direction. It really comes down to a question of how quickly we can wake up to that reality and proactively adapt.
My name is Dr. Andrew Sullivan. I'm a principal research scientist at CSIRO based in Canberra, and I'm the leader of the bushfire behaviour and suppression team. The forecasts that we've seen come from the climate experts are that through the rest of this century, up to 2100, there's a greater chance of increased extreme fire weather, and if that coincides with outbreaks of fires, then we know that we're going to end up with more extreme fires.
Hi, I'm Justin Leonard. I work with CSIRO, and I guess the best description for myself is a bushfire domain expert that's focusing principally on what it's like to experience a bushfire. And that might be from a human perspective or from the perspective of a piece of infrastructure like a car or a house that needs to survive a bushfire. The fire fronts, like a large moving front of fire, could have many shapes. But in terms of thinking about a place in the landscape where a fire builds up and approaches and passes, that process of reaching and passing over a point is experienced like a burn over. So a lot of our colleagues in CSIRO actually study the fire front itself. We use all that kind of data and understanding to create a burnover simulator, which gives us the convenience of being able to build something in place and then create a burnover simulation that pretty much mimics how it would have experienced a fire out in the bush. Shining on your face if you're standing on the window. Interior radiation, 5 kilowatts. Interior 4 kilowatts. Because this program's been running for so long, we've actually had a number of significant fire events where the trucks with these systems fitted have actually been deployed under real fire conditions. Now, Black Saturday fires in 2009, we had a number of actual burnovers, of which in every case, the defence systems that were built and validated using this work actually worked as they intended, and the crews survived each of those burnovers. Well, a lot of our recent work now is actually creating definitions of how bad fires can be at any point in the landscape. And that's for the coming fire season, but it's also for the notion of a fire season most of the way through this century or to the end of this century, because when we think about planning to put houses in the landscape. Those houses will last 50, 70, 100 years. So it's really having a notion of what fires will be like under more climate change going into the future and what they mean houses need to be designed for.
My team undertakes research work to develop the science and technology to better enable fire agencies and firefighters working for those agencies to better understand and predict the behaviour of bushfires. And so we develop the systems that they use for predicting the speed and propagation of bushfires across the landscape. So basically what we're trying to do is to understand the factors that influence the behaviour of bushfires, so that we can identify the conditions under which extreme fire behaviour is likely to occur and be able to predict the likely direction of spread of these bushfires, so fire agencies and particularly firefighters have a better idea of where a fire is going to be so that they can better plan for the actual fighting of the fire, and also identify when warnings need to be issued to the general public. There are a large number of factors that influence the behaviour of bushfires, but we can reduce those down to three main categories of variables. They are the fuel or the vegetation in which fire burns, the weather that drives the fire, and the topography over which that fire spreads. Those three components form what we call the fire behaviour triangle. The thing is that a bushfire can occur in any vegetation at some time. What we can do is basically try to manage the vegetation through which these fires are going to burn. And that brings us to about the only factor out of the three components in the fire behaviour triangle that we've got any control over, which is the vegetation itself. We've built a very large horizontal combustion wind tunnel called the Pyretron, which is located behind me. But we've also built an 11 metre tall vertical wind tunnel that allows us to study other aspects of fire propagation, namely the flight of firebrands, which are called spot fires. These facilities allow us to understand very specific aspects of the mechanisms and processes involved in bushfires, such that we can get a better understanding of exactly how they would behave in the field.
So we really need to drive down emissions to curb our warming climate. That's really the best way we can adapt. In the meantime, our research and practical tools to help predict, fight and withstand bushfires are more important than ever before, as Australia faces continued extreme fire weather events into the future.